Hello and welcome to episode 5 of our Trigonometry Made Easy series. Over the course of the previous episodes, we've covered the 4 main trigonometry methods: Pythagoras' theorem, SOHCAHTOA, the sine rule, and the cosine rule. With so many options available, a natural question arises. How do we know which method we should use? This is a task that many students struggle with, and in this video, we'll take a deep dive into exactly how we can overcome this challenge. In our analysis, we'll focus on 2 crucial questions. First, does the method require a right-angled triangle? And second, how many sides and angles are involved? As we'll see later, being able to answer these questions is the key to correctly choosing the appropriate strategy. Let's begin by overviewing and analysing each of our 4 methods. Pythagoras' theorem states that in a right-angled triangle with a hypotenuse of length h and lengths of a and b for the other 2 sides, we will have h squared equal to a squared plus b squared. This method can only be applied to right-angled triangles. Our diagram involves 1, 2, 3 sides and 1 angle, namely the 90-degree angle. To apply the SOHCAHTOA method, we must have a right-angle triangle which has another angle, theta, marked in. The side across from the right angle gets labelled h for hypotenuse, the side across from theta is labelled O for opposite, and the third side is labelled A for adjacent. There's 3 ratios to choose from in this method. Sine of theta equals the opposite over the hypotenuse. Cos of theta equals the adjacent over the hypotenuse. And tan of theta equals the opposite over the adjacent. Each of these statements involves 1 angle, theta, and 2 of the 3 sides. If you also include the right angle, in total we have 2 sides and 2 angles involved. The sine rule is a versatile method which does not require the triangle to contain a right angle. Given 2 side angle pairs, capital A, A, and capital B, B, we have the following. A over sine of capital A equals B over sine of capital B. In total, this involves 1, 2 sides and 1, 2 angles. The cosine rule is also a general method which does not require a right angle. Given an angle, capital A, and the 3 sides, A, B, C, we have a squared equal to b squared plus c squared minus 2bc times the cosine of A. Counting the sides and angles, we have 1, 2, 3 sides and 1 angle. When presented with a triangle, the first question to ask is whether or not it contains a right angle. The second thing to investigate is how many sides and angles are involved. Considering the case of a right-angled triangle, if 3 sides and 1 angle are involved, then we should use Pythagoras' theorem. On the other hand, if 2 sides and 2 angles are involved, then we should use the SOHCAHTOA method. In the case of a non-right-angle triangle, 2 sides and 2 angles indicates that the sine rule should be used. 3 sides and 1 angle suggests that the cosine rule should be applied. One thing to keep in mind here is that when we are counting the number of sides and angles, we should include the unknown value and the right angle, if there's one present. Now that we've nicely laid out our decision tree, let's see some examples of this process in action. In this triangle, we have the 3 sides labelled as 7.7, 6.9 and 8.6. One of the angles is marked as x. So, which of our 4 strategies is suitable here? Well, first we should check for the presence of a right angle, and this triangle doesn't have one. Immediately, this restricts our possibilities to either the sine rule or cosine rule. Next, we should count the number of sides and angles labelled, including the unknown x. We have 1, 2, 3 sides and 1 angle. The sine rule requires 2 sides and 2 angles, whereas the cosine rule requires 3 sides and 1 angle. Since we have 3 sides and 1 angle, we'll want to opt for the cosine rule. In our second example, we have a triangle with sides of 7, 8 and x. One of the angles is marked as being 90 degrees. First, we should check if we have a right angle. In this triangle, we do, since by definition, a right angle is one which measures 90 degrees. This immediately reduces the possibilities down to either Pythagoras' theorem or the SOHCAHTOA method. Now, we should count how many sides and angles are involved, ensuring that we include both the unknown x and the right angle. We have 1, 2, 3 sides and 1 angle. SOHCAHTOA requires 2 sides and 2 angles, which we don't have. Pythagoras requires 3 sides and 1 angle, which is precisely what we have. So the winner here is Pythagoras' theorem. In our third example, we have sides of 18 and 30. We also have angles of 110 degrees and x degrees. The triangle does not contain a right angle. This means we'll want either the sine rule or cosine rule. Counting our sides and angles, we have 1, 2 sides and 1, 2 angles. The sine rule involves 2 sides and 2 angles, so this is the correct choice. In this triangle, we have an 87-degree angle and sides of 8.2, 11.8 and x. The triangle does not contain a right angle. The diagram involves 3 sides and 1 angle. This is the setup for the cosine rule. This triangle has sides of x and 12. It has angles of 90 degrees and 50 degrees. We do have a right angle present, and all in all, we have 2 sides and 2 angles. This means we should use the SOHCAHTOA method. In our final example, we have sides of 14, 18 and x. We have angles of 90 degrees and 40 degrees. Our triangle does contain a right angle, and this restricts us to either Pythagoras' theorem or the SOHCAHTOA method. The labels involve 1, 2, 3 sides and 1, 2 angles. Pythagoras requires 3 sides and 1 angle, whereas SOHCAHTOA requires 2 sides and 2 angles. As it turns out, our triangle fits both of these requirements. One option would be to ignore the 40-degree angle and then apply Pythagoras. Another option would be to ignore one of the sides, say the 14, and then apply SOHCAHTOA. Hopefully these examples have helped you get a grasp on the procedure for correctly choosing what method to apply. To finish off this video, I'll present several short exercises to give you an opportunity to get some of that all-important practice.